If the moon were to fall from the sky and crash into our planet, the results would be catastrophic. But what if it happened in slow motion over millions of years? What will happen to the moon and our planet, and how long do we have before impact? These are the questions that kept me up at night when I was younger. So, today, I'd like to share with you some answers that scientists have found. The moon has been Earth's companion since the early days of our solar system about 4.5 billion years ago. Since then, the moon has influenced the Earth with its gravity, tides, and even our evolution. But for how much longer? In 1976, two astronomers from the University of Chicago ran some simulations to find out what would happen if the moon crashed into the Earth. They found that if it happened suddenly, most of the moon would be vaporized by friction with the atmosphere, and the remaining rock would form a new ring of mountains around the equator. However, they admitted that their calculation was based on an unrealistic sudden impact. In reality, the moon wouldn't just fall straight into the Earth, but rather gradually spiral into the planet due to gravitational perturbations from other planets like Mars and Jupiter. In 2012, another group of astronomers refined the model and concluded that the moon would indeed slowly spiral into the Earth, losing about 1 kilometer per century. This means we have about 50 billion years to prepare for impact, which is roughly the age of our solar system. It's quite a relief, isn't it? But no, wait, this estimate is based on the assumption that the gravitational perturbations from the outer planets will continue to affect the moon in the same way as they do now. And there is no guarantee that this will be the case. The fact is that even small changes in the mass or orbit of any planet can have huge implications for the stability of the whole solar system. The outer planets like Uranus and Neptune are ice giants, and their current orbits are borderline stable. Any significant gravitational kick could destabilize them and send them crashing into the inner planets. For example, in 2020, one team of astronomers showed that a mere 0.3% change in Neptune's mass could make its orbit unstable and lead to a collision with Earth. That would be bad news for us, to say the least. But even if the outer planets remain stable, the moon's orbit will still shrink due to tidal effects caused by Earth's gravity. This effect is already happening now. The moon is drifting closer to the Earth by about 2 meters per year. Eventually, the moon will reach the Roche limit, which is the closest distance at which Earth's gravity will start to tear the moon apart. Scientists think that this will happen in about 50 million years. At first, the fragments of the moon will form a thin ring around the Earth, similar to the rings of Saturn. But as these fragments fall to Earth, they will create giant tsunami waves that will wipe out all life on the planet. Some of the fragments may also become artificial moons that will stay in orbit for billions of years. Others will plunge into the depths of the ocean and become new islands. Of course, you can argue that we don't have to worry about any of this because we will likely go extinct long before the moon crashes into the Earth. Humanity may face many challenges in the next millions of years, such as climate change, nuclear war, pandemics, and artificial intelligence. But what if we overcome all these challenges and become a space-faring civilization? Will we be able to save ourselves from the moon? One option would be to use powerful lasers to deflect the moon off its course. But even if we manage to push the moon away, it won't help much. The moon will simply return to its original orbit in a few million years because its gravity will drag it back. Another option would be to nuke the moon. A few well-placed nukes could blow the moon to pieces and prevent it from crashing into the Earth. But again, it wouldn't help much because the fragments would still rain down on the Earth and destroy everything anyway. There is only one real solution to this problem, which is to abandon our planet and move to another one. But where to go? Unfortunately, not a single star in our galaxy has been discovered that would have a large rocky planet similar to the Earth and suitable for life. But there is one star that could potentially meet our needs. It is Proxima Centauri. Proxima Centauri is a red dwarf located in the Alpha Centauri system, which is the closest neighboring system to ours. Unlike our Sun, Proxima Centauri is small and faint, but it has at least 2 planets that could harbor life. The inner planet, Proxima Centauri b, is thought to be a rocky world with a thick atmosphere and a strong magnetic field. Scientists think that this planet could have a liquid water ocean and a mild climate, but it also receives 4 times more radiation from its star than we do. This means that the atmosphere of this planet must be very efficient at filtering out cosmic rays and preventing them from destroying the ozone layer. Otherwise, the planet would be a lifeless desert. The outer planet, Proxima Centauri c, is larger than Earth and probably has a thicker atmosphere and stronger gravity. This planet could have a thick layer of ice on its surface and a vast ocean beneath it, but it also receives 10 times less sunlight than we do, so it could be an ice cube with a thin layer of water on top. So, which one should we choose? Well, we don't know much about either of these planets. Both of them could be potential homes for humanity if we ever need to escape from the doomed solar system. But even if we manage to colonize one of these planets, what will happen to the moon after it crashes into the Earth? As I mentioned earlier, some of its fragments will remain in orbit around the Earth and form artificial moons. These moons will be irregular and won't form a neat ring like the rings of Saturn. Instead, they will form a swarm that will drift around the planet. Some of these fragments will be as large as cities, while others will be no bigger than houses. These moons will differ from natural satellites in many ways. They will have a different shape, color, density, and gravity. Most of them will be dark and reflect little light because they are made of basalt, which is a dark volcanic rock. Some of them will be bright and shiny because they are made of anorthosite, which is a white igneous rock. Some of them will be big and heavy like asteroids, while others will be hollow and light like balloons. Some of them will have weak gravity, while others will have strong gravity. Living among these moons will be both challenging and amazing. On the one hand, they will pose a constant threat to human settlements on Earth. The swarm of moons will bombard the Earth with meteorites and disrupt global communications and transportation. At the same time, they will offer unprecedented opportunities for exploration and exploitation. Humans will be able to travel between these moons using advanced propulsion systems like ion drives or laser sails. They will also be able to mine the moons for resources and build new habitats there. So, will it be better or worse for humans? I don't know. It all depends on how we adapt to these changes. We are a resilient species that has survived many disasters in the past. But we are also a greedy and warlike species that has caused many of those disasters ourselves. I hope that in a few million years, we will become wise enough to avoid the mistakes of the past and build a sustainable future for ourselves. But if not, I hope that some other species will learn from our mistakes and not make the same ones. Thank you for watching this video. If you want to know what will happen to the universe after the heat death, click on this video on the screen. And don't forget to subscribe if you haven't yet.